Hello, everyone. Thank you for joining and welcome to another Contino live session. This is a series of webinars covering the biggest trends in DevOps, data, and cloud computing. Today, I'll be talking about architecture and operating model, Cloud Conundrum. This is an advanced talk. We're gonna enter and meander through the relation between cloud operating model, and the architecture that we're using for our systems in public cloud. The session will be roughly 50 minutes, including a 10-minute Q&A at the end. If you have any questions, make sure to submit these during the webinar. I'll aim to answer as many as possible at the end. Also, this session is being recorded, and everyone here today will be receiving a link to the recording in your email inbox. So if you want to go back and watch it again, you can totally do that. So if you're ready, I'm just going to jump through it. So as I said, who am I today? So my name is Federico Fregosi. I'm Contino's VP of Engineering. I've been with Contino for the past 3 years. I'm responsible for the engineering resources, for the technical strategy of the company, and for all our practices, for the way in which we help all our clients, large regulated enterprises, building on cloud, doing innovation, migrating from on-premises onto cloud. And for all of you that don't know about Contino, super brief introduction about us. Contino is a global DevOps and cloud transformation company. I like to say that we are an end-to-end transformation company with more than 500 people globally, 6 offices all over the world, more than 300 engagements over our years of activity, and more than 150 customers. Contino has worked with some of the largest enterprises on earth, really, on the planet. We work with financial services, public sector companies, as well as telcos, media, other enterprises as well. So what we're going to talk about today is basically a story. I want to tell you a story. I want to tell you that having worked with some of the largest enterprises on earth, on the planet, we work with in a very different way over the years. In 2010, the way in which companies wanted to go to cloud in 2010 is very different from the way in which companies want to go to cloud in 2021. And because we focus on enterprises are very good at seeing what is happening around them in the space and then mirroring this, making sure that they don't want to be the early adopters of our technologies. They want to be there when technology is proven to be mature. This is the standard approach, but the way in which we do this changes significantly in 2021. It's a new way. Why? Well, it's easy because in 2021, nobody that is migrating from on-premises to cloud says, I want to migrate to cloud and use VM and storage disk. Nobody says this in 2021. Everybody wants to move on serverless. It's pretty easy. Companies want to leverage serverless. Serverless, why? Because they want to minimize the operational cost of running their softwares. Companies often have a managed services first approach. They want to leverage platform as a service, software as a service offered by the CSP. They want to leverage, they want to level the playing field. They want to compete with unicorns at their same game. In 2015, to get really clear with you, in 2015, Monzo had a super advanced architecture that no other bank could hope to mirror. In 2021, a bank can go on AWS, go fully serverless, deploy exactly the same Kubernetes cluster, if you want, on AWS, and play level in the field. So everybody wants to say, okay, I want access to that technology. I'm ready to use it. My people want to use it. So what we see a lot is that, especially historically, is that companies are really good at embarking at a tools transformation first, which is proven also in literature, as you can see here, through a wonderful book. It's easier to do this. It's easier to use tools. It's easier to change tools rather than changing the culture, changing the processes, changing the policies, restructuring policies and processes much harder than just adopting a new tool. This we all know. And so far, nothing I think of what I said should be surprising for you. What I think is more interesting is to look at the definition of transformation. Even in 2021, as it has been in 2015, as it has been in 2010, transformation is a significant piece that goes way beyond the tools that we're talking about. Transformation builds upon vision and strategy, and then adds people on top. Culture, which is super important. No culture, no pillars, no fundamentals. But we want that in place, right? We don't want just the tools. We want to build on a definition of the value stream. We want to create first autonomous units within the company that can deliver value to customers in the fastest way possible, in the most autonomous way possible to reduce the communication dependencies. We want to have monitoring, we want to have telemetry, we want to have a very modern approach to this. Only a few weeks ago, a report called State of DevOps 2021 has been released. It is what is called a DORA report. For the first time, documentation is clearly called out as a key predictor of success for companies. Companies that have good documentation, companies that have very good documentation, are more likely to be faster at delivering code than their counterparts. We see that all of this is necessary even before we get to technology, even before we get to product development, FinOps, Lean, even before we get to CI/CD, security, shifting left security. All of these activities are built upon a company structure. They're built upon an operating model. If you're just going with the tools, you're building something without starting from the fundamentals. And here's the trick, because the trick is leapfrogging transformation. If you ignore the cultural, organizational challenges and you just focus on the tools, you end up in a place with more complexity and higher risk. Because if you run before you walk, you end up in a place where you have a completely different operating model that you need in order to adopt serverless. Especially when it comes down to these complex new technologies, you will find that a lot of enterprises operate with these complex technologies at a low level of maturity. So it's kind of like a big problem because you start jumping to cloud, jumping to the most advanced technical solution you can choose, but your company is not set up for using that solution, and your people in the company are probably not as experienced as they are with running a solution on EC2 instances. This results in what I call a no man's land of compliance. It's a place in which we've seen a number of times a small business unit within the company, maybe a digital function, spun out, will start building a lot of technologies in very different ways from the main unit, from the main enterprise. And when it comes down to reconciliating that, when it comes down to bringing the innovation back into the company, oh, then it's impossible, because all the functions that were necessary that should have brought in on the journey have been ignored. And as a result, there's resistance, there's friction. The innovation that's been created cannot be scaled. So my talk today, and we're going to talk about today, really is the focus at the center of three different angles. On one hand, we have cloud architecture. What is the technology you're choosing? To get really concrete, Kubernetes, serverless, VMs on EC2, on AWS, or this is one angle. The other angle is the cloud operating model that we're adopting, how we're going to structure our company to make use of cloud in the best possible way, and the organization engineering maturity. Based on the architecture that we've chosen, how ready are we to make use of this architecture? This is where the talk is focused on. This talk is a talk of ideas, and I hope that you will get some of the ideas with you at the end. You can carry with you. We'll see the takeaways. So let's start with some basic principles first. Step one, what is a cloud operating model? So we talked about this briefly before, but transformation, a cloud operating model is a collection of a lot of different activities, of different parts. We have cloud governance first, which is fundamentals, which is the way to ensure that cloud is adopted in a compliant and standardized way across the company. We have cloud metrics that include FinOps, that include the cloud consumption, cost, that include utilization as well. We have cloud organization, how our teams and people are organized to make use of cloud, and DevOps transformation with it. Cloud technology, what technology we're choosing, and the operating building blocks. So the operating building blocks are super important because you don't want each one of your teams to adopt cloud in a slightly different way. You don't want to have team A adopting EC2 and team B adopting EC2 in a slightly different way. Maybe team A is using an antivirus, maybe team B is not using antivirus in the end. And then we have all the value delivery chain. We need to have this structuring of the company, of the department of the company in a way that all our value streams arrive to the customers in the fastest possible way. We have autonomous parts within the organization that can then both leverage cloud as well as their autonomy to deliver value with their products back to the customer. So in all of this, aligned to all of this operating model de facto has been standardized for a number of years. So there is this traditional Gartner's bi-modal operating model for cloud usage. So we start on the left with we have mode 1, traditional operations, where we have cloud managed services, typically, and cloud platform teams. And on top of them, the applications. So in mode 1, you really have an operations team and a development team. They're separate in cloud. The operations team supports the VM and the applications. Instead, the applications team looks after the applications, and they stay separate. There's this handover activity in which one team looks after the run and the other team looks after the build. This is what we call also mode 1 or traditional operations. Over the years, we got in DevOps. We said, okay, cool. So DevOps in cloud, what does it mean? Well, we have two slightly different ways of doing DevOps in cloud. So we have distributed and decentralized DevOps. Mode 2, which stays with Gartner, and mode 3. So mode 2 is once again a place where we have a cloud platform team that enables the application teams to deploy their own apps autonomously. There's still a platform team. The platform team operates the platform, does not support the application, that instead are looked after by their own developers. And then we have mode 3, separately, decentralized DevOps, when now the cloud platform team is really just a consulting enablement team that creates best practices, that creates activities, but is not looking after the day-to-day run of each team. They're just very, very thin layer, creating best practices. To get concrete on this, so mode 1 is EC2 instance, typically is EC2 instances, one operations team running the instance, developers are handing over the code. Mode 2 is most commonly seen as Kubernetes cluster, deployed where you have a platform team operating the cluster, applications team operating the application on top of the cluster. Mode 3 instead is what we were saying before, is serverless. Serverless where you have AWS or GCP or actually the cloud provider operating their entire stack. And then you have a platform team establishing best practices across the company, operating in a governance consulting mode. In all of this, within an enterprise, we typically have a changing role, which is the role of the enterprise architecture. The enterprise architecture changes and shifts from one mode to the other because it moves more and more from a mode in which you're gatekeeping the access to the systems, or you're gatekeeping the creation of new products in the company, to a place in which you're consulting and you're advising teams, creating best practices by automation that can be automatically deployed without your intervention. And so we have then different scaling models required based on different modes. What is the multiplier effect here? Well, it is pretty obvious, but we see more and more that minimizing the cognitive load onto teams is a predictor of performance. So teams that operate with a small cognitive load, teams that don't have many dependencies, can be much faster at developing application, can be much faster at supporting application even. When you have low automation instead, whatever is the technology that you choose, EC2, Cube, serverless, you have typically a high cognitive load. And as a result, low performances because you need a lot of coordination and your teams do not have much autonomy. So let's now join the dots. Let's see with some examples how we can pull everything together. Operating model, cloud architecture, and engineering maturity. So first example, let's just assume for a moment that we are part of a mass migration. We're migrating 15, 20,000 VMs from multiple data centers onto our cloud provider. We're going to use AWS because it's easy. Because, most of you, I guess, will know AWS. So in this migration, what happens? It happens that at some point, after having migrated 1,000, 2,000, 5,000 VMs, typically Windows machine, I would even argue, in the cloud, well, at that point, some of the developers say, oh, I just want to migrate this to EC2, to Lambda. I want to migrate this to a serverless function in production. Now, this is a problem. It's a problem because when we created the migration, because the company is doing its first trial with serverless, what it means, okay, how do I satisfy the compliance requirements of running an application in Lambda if my compliance requirements is using an antivirus? Well, it's a bit of a challenge for sure. I'll be required to cross-train developers. They need to understand how to use Lambda. Upskilling security, explaining them, okay, we don't really need an antivirus on a serverless function because of these reasons. I will need to change all my automation and pipeline controls. This is not only about changing the CI/CD pipeline to point to a different endpoint. No, we're changing the processes. Who's gonna approve which deployment? Who's gonna say yes? Because compliance, especially in large enterprises, gets really significant and cannot be just ignored. In other words, we're changing our policy and process for production. If you think about this, migrating VMs running on premises in mode 1, so development and operations team, moved to AWS, to a cloud provider, in mode 1, EC2 instances, and applications and operations team in AWS, is a mode 1 to mode 1 migration. That was easy. But the second in which a developer says, I want to use serverless, so I want to use a different mode, then I have mode 3 application that requires to be supported in a different way. And even if we try to apply our development and operations mode to serverless, and some companies do that, so you have your developers that will write code to a Git repo and operations team that will deploy the code on Lambda manually or semi-manually, well, I'm still going to lose a lot of the benefits of the fast iteration cycle. I'm going to lose a lot of the benefits. I'm going to still face a lot of problems having to change my policy for production. So if I try to mix mode 1 with mode 3, it's a problem. I just try a different way. Let's just do a second example. In a second example, we have a company that is full on cloud, as almost a cloud native company. This company has been running a serverless architecture and it only has serverless solutions. Staying in AWS realm, we have DynamoDB, we have Lambda, we have API gateway, and we have all of this. And the company has structured itself to get all the benefits of serverless. So there's not really a policy that says you need a antivirus in your VM, because they never run VMs. What happens is, as part of the work, you need to deploy a COTS. So if at some point in your serverless architecture, you really need to integrate a soft HSM, or maybe you have to connect to Swift and you need to deploy a VM for that. How do you do that? Well, you can say, well, I have cross-functional autonomous teams that are just fully autonomous and fully deploying on Lambda. I can just ask one of these teams to look after my VM as well. They will know how to do it, right? Will they? Well, in most cases, it turns out that developers that are using serverless, counterintuitively, they need to be better at operations, but and developers that are used to serverless and need to go back to EC2, they need to learn how to do operations on EC2. So you need to upskill developers, which will take a while. You need to upskill security as well, because security needs to create new policies that say, maybe we don't need an antivirus on Lambda, but we may need one on EC2 if it's running on COTS that we don't know about. We need to review automation and pipeline controls as well to deploy on this VM. And in the end, we have once again to think about who is going to patch the VM in 3 months. We have to think about changing policies and processes for production. In this case, we had a company running serverless mode 3 architecture that embedded a piece of software that could only run on a VM as an executable running on Windows in mode 1, typically. And then there's a starter question. Then there's the most common question that we see a lot of our customers asking us, is the Kubernetes clusters question. Operating with large enterprises, we often hear the question, how many Kubernetes clusters should I run? Should I have one cluster for all my business units operated by one team, Or should I have a lot of clusters operating in a lot of different ways for a lot of my teams? And it's an honest question. It's a very good question. It's an honest question because the answer, as in most cases, is it depends. It depends on something, right? Because we have examples of successful companies that do both things. We have very successful companies that have one OpenShift cluster running in one environment, and this OpenShift cluster supports a lot of the company, or at least the entirety of the department. And we have other companies that operate a lot of Kubernetes clusters, a lot of small clusters, each one supporting only one or a few applications. So in our world, if you think about this, mode 1, 2, and 3, we can start quickly realizing that a system, Kubernetes, that has been designed to be operated as mode 2, so having Kubernetes is a complex piece of software that is very rarely deployed by only development team. They will be an operations team supporting Kubernetes and the platform. Okay? So you have a mode 2 workload designed for mode 2, and you're asking, should we run this workload in mode 2, or should we run a workload designed for mode 2 in mode 3? Because to be honest, I really want to run my Kubernetes cluster in mode 3. I want to run 50 clusters with full autonomy for each one of the teams. With doing that, I will get isolated faults, reduced blast radius. I will have a lot of autonomy for the teams that will not be dependent on platform team, quick iteration. And also, frankly, if I'm running an OpenShift cluster on premises already, as most companies will, well, there's no need for me to change the policies for production. I can do that, right? Can I not? Companies are successful at this. The known retail company Zalando. Zalando is a famous example of a company that has created a lot of automation to build all of this, because this is the trick. The trick is for you to be able to run multiple Kubernetes clusters, assigning each cluster to one team, you need to have significant amount of automation. You need to have, example, Terraform modules for each Kubernetes cluster. You need to have all the components running in the cluster deployed at creation time, container security policies, container runtime security, CI/CD pipelines, service mesh, if you're using a service mesh. You need to manage the upgrades of the nodes, the upgrades of the cluster, the API service, as well as the nodes, depending on your deployment. You need to have an external validation to the design and config of the cluster. Most likely, you won't be able to just deploy your cluster. You need somebody to approve the deployment of the cluster and the choices that you're making. You need to implement then all the company policies that can go from privilege escalation. How do I get admin access to the cluster? To how do I introduce MFA? All of this in place. In other words, if you're taking a mode 2 system as Kubernetes, operating it in mode 3, you're putting a lot of operational burdens on your shoulders. But as we said, companies have done it successfully. So what was the thing that they had in place to run this activity successfully? Well, they had all that automation in place and more. They were very mature, in other words, in the way in which they were adopting cloud, and they were adopting mode 2 workloads. So can I have multiple clusters? Yes, if you have a high level of engineering maturity. This is where we introduce engineering maturity. This is where we introduce what level of maturity you have in your company today. Because if you think about this, at high level of engineering maturity, so if your company is structured with autonomous teams that can operate fully autonomously because you created the operating model around that. If your developers as well know how to do it, so they have this in place, if the CI/CD is in place, if the policies and the processes are in place, then you can definitely have multiple clusters, and you likely should have multiple clusters, because those clusters will give you velocity. Those clusters will give you autonomy and an easier compliance journey. But if you're a company that is just adopting serverless technologies, Kubernetes as well, if you have a low level of engineering maturity, then you want to take a mode 2 workloads and run the workloads in their own mode. So operating a system that was designed with an operations team supporting it with exactly an operations team supporting it, with the applications team just deploying stuff on their cluster. This is the key of the talk as well, that we'll see repeated a number of times, which is thinking about the level of engineering maturity in a company and the level of organizational structure. There's three-dimensional metrics to define the way in which we want to adopt cloud, define the way in which we want to deploy our applications. So we're going back there. We're going where we were before. We're thinking again of what is the juncture between a cloud architecture, operating model, and organizational maturity. Last example. Oh, this is interesting. So what happens when I try to deploy a Lambda function mode 3 as part of a fully mode 1 migration? We see it a minute ago. In example 4, we're reversing the game. We're saying, what happens when in a company that is running a series of Lambda functions, we deploy a new application in a different way? The application perhaps is running in a Kubernetes cluster. With an application running in a Kubernetes cluster, well, I need to decide how are my Lambda functions going to integrate with the Kubernetes cluster, okay? Yes, I can deploy the application in the cluster, but who's going to support the cluster? I will need once again to cross-train developers, upskill security, review the automation and the pipeline controls. In other words, it doesn't really matter in this case either. From mode 1, having a serverless system with a COTS, or having a serverless system with components deployed in a Kubernetes cluster, explodes your technical complexity. Once again, your bill of materials gets really, really big. You end up needing a lot of automation in place. So you want to really ask yourself, what is my level of maturity of automation? Because if I start mixing things up, I get complexity very, very quickly. Not to mention the fact that realizing the network connectivity between Lambda functions and Kubernetes is still something that needs to be looked after today. So what are the takeaways of my talk before we jump into the questions? And by the way, if you have any question, it's a good time to write them down in the chat. So takeaways is that when I have to deploy a new system, when I have to deploy something new in cloud, I really have 3 switches only. I can think at architecture, operating model, cloud operating model, and engineering maturity. I have these 3 switches that I can control. I have this significant piece of work that I can control. I can choose I can have a low or high, but it will take me a long time to change them. So I have the opportunity of controlling them, but they are very long to change. It will take a long time to change. There's a very long response time. So those switches are very hard to click. They're very hard to move. And we need to assess when we start a new project, what is the level of maturity of the company? Because the reality is that at low levels of engineering maturity, we can break the connection between cloud architecture and operating model. You're forced to use technology as defined. Choosing one implies choosing the other. The sole thing is a new type of trade-off that I see enterprise architects in companies having troubles with. Oftentimes, they forget about this role and end up paying a price, risking the adoption of cloud when we say, oh, cloud doesn't work for us, because we tried the technology that all the others have used, we tried the tools, but it failed at our place. This small conundrum is a subtle thing, but it's the first time I think that enterprise architects are required not only to think about, there's a lot of work on their plates, because they're not only required to think about the architecture, the business, so does it make sense for us to build this product within the business context, but also how will we structure the business, the company to support this? What are we going to use this in the company? So we're transcending completely the realm of IT, and we're entering a world where business IT are one thing and one thing only, and only in that way we can get the benefits of IT with a lot of autonomy and we can get the benefits on the business side with a lot of velocity. Let's see, a few ideas here. So just to reiterate this concept, in terms of key predictors of success, when the engineering maturity is low, choosing a cloud architecture implies choosing an operating model. If I choose to run a Kubernetes cluster which is a system built in mode 2, I should operate the system in mode 2 as well, with an applications team able to deploy autonomously and a platform team supporting the cluster. When instead engineering maturity is high, when I've been doing this for a while, when I have all the automation in place, all the processes in place, I can separate them. I can have Kubernetes operated by multiple small value streams, small cross-functional teams. In the same way, thinking about serverless, if my company has never adopted serverless, we likely don't want to enable any developer in the company to choose the serverless functions that they want and integrate them as they want. We likely want to use the autonomy given by cross-functional teams for them to be able to iterate autonomously, building their own functions and delivering value to their customers in a way that we have that type of test in place. When the engineering maturity is really high, when I have everything in place to ensure that any developer that wants to use serverless can use serverless very easily because it will be automatically integrated to the right network. We'll have the right level of monitoring in place autonomously. When you get all of this, then you can use your operating model and your system in the way you want. You can use serverless, mode 3, in different modes as well, if you want. It's a key predictor. In other words, respecting the green zone is a key predictor for success. Your digital transformation is well positioned for success. So if you stay within the boundaries of your level of engineering maturity and your level of adoption of technology. If instead you break the rule, if you try to use Kubernetes in mode 3 without having any engineering maturity in place, you will see what we see in a lot of companies. You risk failing your migration because your teams will be like, I don't know how to use this. This is too complex. It will take us 6 months across all the teams to build all the automation that we need in place. So thinking about your application, thinking about what you're doing, what I want you to take away from this session are 2 key questions. Before adopting any technology, before modifying an existing technologies, you should ask yourself, what is our level of engineering maturity in the company? And what cloud operating model are we going to use? How are we going to use this technology in our company? These are the same questions that you will need to ask yourself when organizing the organizational structure, when designing the organizational structure of an IT department. What is our level of engineering maturity? Can I create this autonomy in place, or I cannot? Because if I create the autonomy, I will have a huge backlog of technical debt that needs to be solved because the systems were never designed to be built in an autonomous way. This is the other side of the coin. You see that the 3 parts of our triangle are really well connected. We see companies failing at both sides. We see companies failing at adopting the wrong technology, and we see adopting the wrong technology in the wrong way. And we see companies that structuring themselves for a super fast, super advanced way of organizational design without having thought about the fact that they only have one monolith and it's just impossible to break the dependencies. So all this cross-functional teams will have a significant cognitive load, having to stage all their deployments, having to organize and connect with a lot of other teams as well. So this is the takeaway. Think about your level of engineering maturity and operating model when adopting a new technology in cloud, because cloud gives you a lot of opportunities to do a lot of different things in a lot of different ways. Now, this is a good time for you to ask questions. I'm going to get a sip of water and I'll get back to you. Let me see if there's any question. Okay. So the first question is, Should we not use COTS with cross-functional teams? This goes back to my second example. So should we not use COTS with cross-functional teams? Should we not use executables running on their own VMs when we have cross-functional teams? The answer is no. You can use COTS with cross-functional teams if your teams are ready to use it. If you have built that level of engineering maturity, if you created the policies if you have all the policies in place, if managing those policies as well will not represent a significant level of operational burden, if your teams will need to run a lot of maintenance on the VM that operates the COTS and they're blocked to do all their development work, then maybe it doesn't make sense for you. But if you build the automation and you have that in place, why not? Of course. And then we have our second question, which is what about a startup? Do we need to worry about all of this? So if you're a small startup, if you're a smaller company, do you need to worry about all this? I think you should. You should definitely think about this as well. Startups are likely to start fully cloud native these days, starting with serverless, being really, really advanced. So the challenge that you will face is the fact that in growing your company, as we see in other financial institutions as well, you're creating your fintech, you're starting and you're fully cloud native. You're maybe running Cube, maybe you're running a serverless. And then at some point, you need to connect with the Swift payment system. You need to connect with technology, you have to connect cables with the trading floors. So you have something in place that forces you to choose a VM, to choose something else. So the point is, when you will be adopting that VM, adopting that technology as well in your startup, don't do that in a naive way. Just say, oh, we're just gonna give it to that team to use it, they will be fine with it. No, instead, use the opportunity to spend time and build the right policies and processes, such as you enable the company to take that in place, to take that level of autonomy completely in place. Okay, I think that these are all the questions that we have. So I think that's all we have time for today. Thank you. If there are no questions, I think we can wrap up here. I think it's good. So thank you so much for joining today. Make sure to check out some of our past Contino Live webinars on contino.io/events, or you can also keep an eye for any future webinars. Thank you very much and goodbye, everyone. Bye.